Hey Math 20-2s. Today we're going to do some problem solving involving quadratic equations. Let's look at example 1. The height h meters of a projectile above the ground at time t seconds after the launch is given by the quadratic equation. H at t, so height in meters after time t seconds, is negative 4.9 t squared plus 16t plus 2. A, write a quadratic equation which could be solved to determine the time it takes for the projectile to hit the ground. So a quadratic equation doesn't have two variables. This quadratic function has h and t in it. What is the height when the projectile hits the ground? Well, that height is 0. So a height of 0 should equal negative 4.9 t squared plus 16t plus 2. Algebraically determine to the nearest tenth of a second the time it takes for this projectile to hit the ground. So algebraically we could solve this by factoring, or we could use the quadratic formula. Seeing as that looks like it's a pretty tough one to factor, let's use the quadratic formula. A would equal negative 4.9, B would equal 16, and C would equal 2. So our variable in this equation is t, so our quadratic formula should say t equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right. It wants this to the nearest tenth of a second. So let's figure these out. Negative 16 plus or minus the square root of 16 squared. So 16 squared is 256. Minus 4 times negative 4.9 times 2 is plus, what's 39.2. All over 2 times negative 4.9 is negative 9.8. All right, so let's calculate t. Let's use our calculator. Negative 16 plus the square root of 256 add 39.2 and divide that by negative 9.8. Negative 9.8. And we get about negative 3.4. So one answer, t is negative 3.4. Or the other answer, negative 16 minus the square root of 256 plus 39.2 divided by negative 9.8, which is positive 3.4. So the time it takes to hit the ground is about 3.4 seconds. Negative 1 doesn't make sense in this case. All right. Example 2. A special enlarger bulb is designed to enlarge photographs from a 4x5 enlarger so that the reflector takes the shape of a parabola if viewed from its side. The depth of the reflector is 2 centimeters. When placed on a coordinate axis, the equation of this parabolic reflector is given. Write a quadratic equation which could be solved to determine the diameter of the reflector bulb. All right. So if we're looking for the diameter, that occurs at the two x-intercepts. So I want to set the y value equal to 0. So 0 equals negative 2/9 x squared plus 4/3 x. Write an equivalent quadratic equation using only integer values. So they want to get rid of all the fractions. So if I were to multiply the whole equation by the lowest common denominator in this case of 9 and 3 is 9. So I multiply the whole equation by 9, I'm going to get rid of the fractions, and I'm left with only integer values. So 9 times 0 is still 0. 9 times negative 2/9 is a negative 2x squared. And 9 times 4/3 would be 12x. 9 divided by 3 is 3. 3 times 4 is 12. Part C, determine the diameter of the reflector bulb by finding the roots of the equation. In B, by factoring. So 0 equals, take out a common factor of negative 2x. I'm left with x minus 6. And now I can set each variable factor equal to 0. So negative 2x equals 0. Or x equals 0. That's one solution. Here, x minus 6 could equal 0, or x could equal 6. That's the other solution. So those are our two x-intercepts. All right, one at 0, one at 6. So answer the question, the diameter of the reflector is 6 centimeters. I believe this was in centimeters. Yeah. Yes, it was. All right. Great. Let's look at modeling a situation with a quadratic equation. So some problems in math can be solved by the following procedure. Introduce a variable to represent an unknown value. Sometimes we can do this with a diagram. Form a quadratic equation from the given information, solve that equation, and then state the solution. All right, so those are our 4 steps every time. Example 3. The paved walkway from the main school building to the physical education block at a school is L-shaped, with a total distance being 230 meters. A student taking a shortcut diagonally across the grass shortens the distance to 170 meters. Draw a sketch to illustrate this information. So you've got an L-shaped paved walkway. All right. Total distance there is 230 meters. A student takes a shortcut diagonally across the grass. We know that's 170 meters. We're not sure what this distance is, but I know this distance then should be 230 minus x, because these two added together should add up to 230. If one of the L-shaped sides has a length of x, state the length of the other L-shaped side in terms of x. So I just did that. One is x, the other one's 230 minus x. Part C says use Pythagorean theorem to write a quadratic equation in terms of x and then solve the equation to determine the lengths of the 2 legs of the paved walkway. So according to Pythagoras' theorem, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. So there's our quadratic equation. Now all we have to do now is solve it. All right. So let's solve this equation. We'll need a calculator. What is 170 squared? And 230 squared. So 28,900 and 52,900. So 28,900 equals x squared plus 230 squared, we said was 52,900. So square the first term, multiply those 2 terms together, which is a negative 230x, and double it, so that's a negative 460x. And then square the last term. Now let's set this equation equal to 0. So 0 equals x squared plus x squared is 2x squared. I've got a negative 460x, and I should minus 28,900 from both sides. So 52,900 minus 28,900 is 24. All right. And now if I want to simplify this equation, I can divide everything by 2. So 0 divided by 2, 2x squared divided by 2, 460 divided by 2, and 24,000 divided by 2. And we have a little simpler equation. Now, solve that equation any way we want. We could figure out this using the quadratic formula, but I think it might be easiest to factor this equation. All right. Only way to get to x squared is to have an x in the front of each bracket with two numbers multiplied at 12,000, add to negative 230. Let's figure that out. So to find the factors of this, two numbers that add to negative 230 multiplied at 12,000, we're looking for some factors of 12,000 that are pretty large. So, I mean, if we go to our calculators, take 12,000 divided by, say, 60. 60 and 200 get close to 230, but that gives you 260 or 140. So what about 12,000 divided by 70? Maybe it doesn't work real nice. No. What about 12,000 divided by 80? Hey, 80 and 150 add up to 230. So there are our factors. Awesome. All right. So we want 80 and 150. Both these would be negative, and there are our factors. So set each factor equal to 0. X minus 80 would equal 0, or x minus 150 would equal 0. We've got two solutions, x equals 80 or x equals 150. Now let's answer the question. Go back up to the original question. If x is 80, 230 minus 80 is 150, and if x is 150, 230 minus 150 is 80. So the other two legs of the triangle, or of the paved walkway, are 80 meters and 150 meters. All right. Beautiful. Let's look at example 4. Last year, a theater company had 720 season ticket holders. The manager of the theater company has decided to raise the price of a package of season tickets for the new season to generate more revenue. The existing cost of a package of season tickets is $140. So before raising the price of a package of season tickets, he hired a market research company to gather data on the proposed increase. The research company reported that for every $5 increase in price, approximately 20 season ticket holders would not renew their tickets. The manager decides that the price increase will be multiples of $5. Let's complete the following table. So the number of $5 increases, 1, 2, 5, 10, and so on. Cost of season tickets. Well, the original cost of a season ticket was $140. So the original cost was $140, and they sold 720. So the original revenue, if we want to figure that out, 140 times 720. That's 100,800. All right. So if we have one ticket increase of $5, the new cost of season tickets is $145. We would lose approximately 20 season ticket holders, so that would get us down to 700. And the new revenue generated would be 145 times 700. So you try that, you get 101,500. If we have two ticket increases of $5, we get to a season ticket price of $150. We lose another 20 people down to 680. So the revenue would be 150 times 680, which is 102,000. 5 ticket increases. So from 140, we're going to add 25, so that's $165 for season tickets. We would lose 20 people every increase, and we increased 5 times, so 20 times 5 is 100. So we lose 100 season ticket holders. We're down to 620. So 165 times 620 is 102,300. So we're still making more money. If we have 10 ticket increases of $5, that's a $50 increase added to the 140 is $190. We lose 10 times 20, which is 200 people, so we're down to 520 people buying season tickets or renewing them. And that gives us 98,800. So at this point, we're no longer making more money. We're now losing money if we increase it too much. If I increase it X times, well, each increase is $5, so 5 times X, and we're adding that to 140. That's what we're doing all the previous cost of season ticket boxes there. Number of season ticket holders. Well, we're losing 20 season ticket holders every time we have an increase of X. So I started with 720 season ticket holders, and I'm losing 20X of them. And then our revenue, of course, would be the number of the price of a season ticket, 5X plus 140. We multiplied that by the number of season ticket holders, 720 minus 20X. So that's our revenue. Part B says, write a quadratic function in the form r at x equals ax squared plus bx plus c, which represents the revenue obtained if there are x $5 increases in the season ticket price. Well, that's that last row we've written. So revenue in terms of x would equal, I just want to expand out this bracket, right? 5x plus 140 multiplied by 720 minus 20x. Right, so they want it in this form. I want to expand out the bracket and collect like terms. So 5x times 720. Let's do those numbers. 720 times 5 is 3,600. 3,600x. And 5x times a negative 20x is a negative 100x squared. Then 140 times 720, we've done that one already. 140 times 720 was that original up there. 100,800. So plus 100,800. And then 140 times negative 20 is a negative 2,800x. So if I want Rx in the simplest form there, we want our x squareds first, so negative 100x squareds. Then combine our x's, 3,600x minus 2,800x is a plus 800x. And then we've got 100,800. All right. Part C, write a quadratic equation which would be solved to determine the number of $5 increase required to generate $102,000 in revenue. Well, this right here is what stands for revenue. So I want to write 102,000 should equal negative 100x squared plus 800x plus 100,800. All right. So you're going to go to the next page now. It asks you to solve this quadratic equation. Solve the quadratic equation and C to determine the number of $5 increase required to generate $102,000 in revenue. So we said that equation looks like this. $102,000 equals negative 100x squared plus 800x plus 100,800. So to solve that equation, we're going to set it equal to 0. So you get negative 100x squared plus 800x. And we're going to minus 102,000 from both sides. So we minus 102,000 from that, we get negative 1,200. All right. And what I can now do, if I divide the whole thing by negative 100, if I divide every term by negative 100, 0 divided by negative 100 is still 0. Negative 100x squared divided by negative 100 is 1x squared. 800x divided by negative 100 is a negative 8x. And negative 1200 divided by negative 100 is a positive 12. So that is a much simpler equation to solve, right? So if you want to write down what we did, we divided every term by negative 100. And we got this much simpler equation. And now I can factor this equation. The only way we get to x squared is to put an x in front of each bracket. So what multiplies to 12 and adds to negative 8? That's minus 6 and minus 2. All right. Solve each of these simple equations after we set them equal to 0. So x minus 6 could equal 0, or x minus 2 could equal 0. Therefore, x equals 6, or x equals 2. What does that tell us? That tells us that there's two situations that will occur that will give us a revenue of $102,000. So at 2 ticket increases of $5 each, or at 6 ticket increases at $5 each, $102,000 in revenue will be made. All right. Part E says, determine the cost of a package of season tickets and the number of season ticket holders if the owner of the theater company implements the decrease or the increase in Part D. So at 2 ticket increases, the cost per ticket, cost for the tickets would be $140 plus 2 times 5, or $150. And the number of ticket holders would be 720 minus 2 times 20. So 720 minus 40 would be 680 season ticket holders. But we could also have at 6 ticket increases. Then the cost would be 140 plus 6 times 5. We've got 6 increases at $5 per increase. So 6 times 5 is 30 plus 140, that's $170 for a set of season tickets. And the number of tickets, number of season ticket holders would be 720 minus 6 times 20. So that's 120. 720 minus 120, 600 season ticket holders. All right. F, by graphing the revenue function in B, determine the maximum revenue which could be generated and the corresponding cost of a package of season tickets. All right. So by graphing it, so here we have our revenue in terms of X. Here we've got X, the number of tickets. All right, this is in dollars. X is number of tickets, number of season ticket holders. We're going to want to graph this equation. So Let's go to our graphing calculator, right? All right, so what we want to graph is our original revenue question here. So y equals negative 100x squared plus 800x plus 100,800. So let's go to our graphing calculator and let's graph that. All right. So in our graphing calculator, negative 100x squared. So negative 100x squared plus 800x plus 100,800. And a window setting. Just so we can see the full parabola, let's go from negative 30 ticket increases to maybe 40 ticket increases by a scale of 10. Sure, that'll work. And minimum revenue is 0, maximum revenue maybe 105,000. Go by 10,000. That's not a bad window setting. If you hit graph, there's what our parabola looks like. The question asked us to find the maximum revenue and when that occurred. So if we're looking for the maximum value, we're looking for the vertex. So let's second calculate the maximum value, number 4. Let's get left of that maximum, so let's let x equal 0. Get right of it. I think if we have maybe 10 ticket increases, that's more than enough to get right of it. So now I just have to make I don't have to make a guess. I can go back if I want to guess, but just press enter. And that maximum occurs when x is 4 and y is 102,400. All right. So let's draw this back in our notes. So right around here we get this curve. All right. And this point right here, that x-intercept is 100,800. 100,800. The maximum, all right, occurs when x is 1, 2, 3, 4. And that had a maximum value, if we recall from the calculator. Jeez. This is R at x in dollars. This is 100,800, and we said that maximum was 102,400. So that's our vertex point. So having said that, we should say the maximum revenue is $102,000, $102,400, and the corresponding cost of a package of season tickets when season tickets cost 140 plus 4 increases of $5. So 4 increases of $5 was 20 plus 140, $160. All right. Excellent. You guys have your assignment. Questions 1 through 10. You know which ones to do. Away you go.